Hello, welcome to our group project presentation. My name is Daniel Russell, and together with Elisa Howansky, Hayley Trzinski, and Stephen Shirmer, we will be discussing avian diversity in wetland and urban habitats within the context of the latitudinal diversity gradient. We will begin by defining and describing the concept of the latitudinal diversity gradient. This concept was proposed by Alexander von Humboldt in 1807, and in very basic and condensed terms, it is an ecological phenomenon, whereas one moves further away from the poles, i.e. towards the tropics, the level of biodiversity and species richness increases. The latitudinal diversity gradient is often attributed to the characteristics of lower latitudes and tropical regions. Some of these characteristics include high speciation rates, higher net diversification rates, and lower extinction rates. The latitudinal diversity gradient can be further described by 6 different hypotheses. The first hypothesis is the time hypothesis, which suggests that tropical regions provide more time for lineages to amass species. The environmental heterogeneity hypothesis suggests that habitat heterogeneity encourages species richness. The competition and predation hypotheses sort of go hand in hand with one another in that they suggest, within tropical regions, that competition will be lower overall due to the presence of high predation, which keeps populations in check. The climatic stability hypothesis suggests that there is greater specialization, greater diversity, and narrower niches in tropical regions due to the presence of a stable climate. The last hypothesis is the productivity hypothesis, which suggests that the high productivity in tropical regions promotes species richness. Now that we've explained the latitudinal diversity gradient, let's get into potential alterations to it. Anthropogenic influences can drastically affect species richness and diversity. Some examples of anthropogenic influences include urbanization, agriculture, and recreation. These influences can result in habitat loss, fragmentation, and degradation. We will be focusing on urbanization moving forward in this presentation. We will now discuss potential alterations in the latitudinal diversity gradient concerning avian diversity and species richness through the lens of past studies. Griffith et al. 2025 sought to look at how urbanization affected large-scale diversity patterns such as those seen in the latitudinal diversity gradient. They found that the latitudinal diversity gradient in birds was weaker in urban areas than natural areas across latitudes. Furthermore, they found that tropical cities lost the most species, likely due to the fact that tropical regions have many specialist species that are more susceptible to anthropogenic influence than generalist species. All in all, urbanization was found to disrupt the latitudinal diversity gradient in birds. Santos et al. 2024 revealed that urbanization in a tropical city reduced avian diversity and community composition, with species being less functionally and evolutionarily distinct in areas with high urbanization. They also found that urbanization influenced the selection of traits related to bird weight and tail length. Lastly, Ordonez Delgado et al. 2022 asserts that urbanization has led to a strong decline in avian diversity in the neotropical Andes region of South America, which is one of the richest hotspots for avian diversity in the world. Let's move on to our study goals and hypotheses. We wanted to determine if urbanization had a significant impact on avian species richness within our respective regions when compared to wetland habitats. We also wanted to assess differences in the latitudinal diversity gradient between our urban and wetland sites, and to see if alterations in the latitudinal diversity gradient could be visible within our own backyard, so to speak. We hypothesized that urbanization would result in reduced avian species richness when compared to wetland habitats. We also hypothesized that while avian species richness would increase with lower latitudes, the latitudinal diversity gradient would be weaker in urban habitats than in wetland habitats.
Thank you, Daniel. When we got together and discussed what type of a study we were going to do, we came to the realization that based on our locations in the United States, we aligned perfectly to do a latitudinal gradient study. So we followed the following methodology. First, we identified our latitudinal locations. Second, we selected sites, both urban and wetland. And then third, we collected data. Our group members spanned quite a bit of distance in the United States. Our farthest north, we had a group member in Wisconsin at 44 degrees north, in Pennsylvania at 40 degrees north, in South Carolina at 34 degrees north, and all the way down in Florida at 26 degrees north. This allowed us to analyze avian data over a span of almost 20 degrees latitude in the United States. At each of these latitudinal locations, we chose two different types of habitats. One is wetland and the other is an urban site. And what we defined wetlands as habitats that were located near or adjacent to areas that were large bodies of water, marshes, lakes, or mangroves, and relatively removed from larger scale urbanization. In picture A, we see our Wisconsin site, and this is near Wisconsin Rapids, Wisconsin, and this is Lake Nepco. In picture B, we see close to Naples, Florida, this is the Gordon River Greenway Park. In picture C is in Greenwood, South Carolina, and this is the Grace Street Park. And in picture D is New Bloomfield, Pennsylvania, and this is Holman Lake Inlet. For our urban site locations, we selected areas that were defined as those having high levels of anthropogenic disturbance, such as large numbers of buildings, living areas, high human and vehicle traffic, and impervious surface. So in picture A, our Wisconsin location is in Wisconsin Rapids, and this was a residential area and church grounds. Location B was in Naples, Florida. This was an apartment complex. Location C in Greenwood, South Carolina. This was a medical complex. And in location D in Pennsylvania, this is in New Bloomfield, and this is the town square of the county seat of Perry County, New Bloomfield, Pennsylvania. In terms of data collection, over the study period, we performed a walking survey at each of the locations and accrued 5 to 6 hours of data walking between 8 a.m. and 12 noon. We identified species only once per day in order to avoid double counts. We also identified the species with the aid of the Merlin Bird ID and eBird. We also noted whether it was vocal only that we confirmed, and then if it was both vocal and visual. And we excluded any species that were unidentifiable. During this time, we also documented the date and the time, along with weather conditions. We also recorded behavioral notes that we observed at each location. Now on to Elisa with the data analysis.
I'm Elisa, and as Steve was telling you, the type of data that we collected was basically a count of all of the species at each site on any given day and any given trip that we took. What we ended up doing was pooling all of the trips for each site into one pot to calculate an overall site species richness with no duplicates of species counted. This, however, was not able to be used for data analysis because with each of those being a single value, there isn't any sort of meaningful variance that can be used for statistical analysis. In lieu of this, we ended up using daily species richness, and that allowed us to calculate a standard error, which was then able to be used to perform statistical analyses. These statistical analyses were performed in R and RStudio, and no additional packages needed to be loaded for these to happen. So the first test that we performed was a one-way ANOVA. This was meant to distinguish whether or not there were any differences between any of the associations overall. It didn't actually tell us between which associations those differences occurred. And those associations were in wetland or urban, Florida versus Wisconsin, South Carolina versus Florida, etc. So any of those kinds of associations. If any difference was shown in our one-way ANOVA, we used a 2 keys on a significant difference post hoc test to tell where those differences were actually occurring. So was it between Wisconsin, Florida, South Carolina, Florida, etc. And here shown on the right, on the left pictures are from our Greenwood wetland site, and on the right is pictures from our Pennsylvania site. What you're seeing right now is our overall site species richness. On the y-axis, you see overall site species richness, and on the x-axis, you see state. The green bars indicate wetland environments, and the gray bars indicate urban environments. The important thing to note for this one is that on average, all of the urban sites had lower species richness than any of our wetland sites. The interesting thing to note is that Pennsylvania had the highest species richness, overall site species richness of all of our sites, and Hayley will be able to give you some insight into why that might be, but this was certainly not expected. The more interesting graphs are the ones with daily species richness, where we were able to perform our statistical analyses. On the y-axis, the only thing that's changed is that it is now daily species richness rather than overall site species richness. Green is still wetland and gray is still urban. The double asterisks indicate that that value was significantly different than the other single asterisk values. So in our wetland associations, we ended up finding that Pennsylvania had the highest daily species richness out of all of our sites. Hayley will comment on what that could possibly mean in our discussion. And the other 3 sites in our wetland habitats did not have a significant difference between each other, though Wisconsin is slightly lower than Florida and South Carolina. In our urban habitats is where we start to see what is more consistent with what we were expecting to see, which is that Florida, South Carolina, and Pennsylvania are not significantly different than each other. They are slightly closer together than Wisconsin is. And Wisconsin is significantly lower, which is our highest latitude site. And now we're going to go on to Hayley, who will tell you a little more about what these results mean in the context of our study.
Hi, I'm Hayley Trzinski, and I will be covering the discussion and conclusions portion of this presentation. For our project, our first hypothesis was that urbanization would result in reduced avian diversity than wetland sites. And we found that wetland and urban sites did differ for species richness, where wetlands experienced higher diversity throughout all of our sites, but Pennsylvania was significantly higher in this diversity, possibly due to a larger amount of adjacent forest habitat and other habitats, and also due to other unaccounted for circumstances. And this lines up similarly with the results of the Griffith et al., Santos et al., and Ordonez Delgado papers, where they mention that urbanization reduces avian diversity. Our second hypothesis was while diversity would increase with lower latitudes, the latitudinal diversity gradient would be weaker in urban habitats than in wetland habitats. And our findings were that biodiversity or species richness significantly differs along the latitudinal gradient between Wisconsin and the other states for urban habitats, but not for wetland habitats. So Wisconsin was the only state that was significantly different than the 3 other sites. It was much lower in diversity in the urban habitats, but not in the wetland habitats. So the latitudinal diversity gradient did not match up with our data for the wetland sites. And so I say on here that this was opposed to the Griffith et al. Paper because in that paper they say that urbanization should reduce the strength of the latitudinal gradient hypothesis, but we saw that the urbanization kind of increased the latitudinal gradient hypothesis in this case, where Wisconsin was lower than the rest. Some study limitations and biases that we wanted to mention were that observer and ID skill bias was probably an issue. There's room for further improvement here. So we all have different amounts of skill and experience with birding. So depending on how good we were with that, which species we knew, that is something that we could improve on. We all used the Merlin Bird ID app, and that also could have had some accuracy issues depending on if a bird call was really quiet. It might have ID'd the bird incorrectly that way. And then we also had different survey, not types, but we moved around our sites. So we didn't do a typical like point survey or a transect survey, but we kind of randomly moved around our sites. We didn't pick one spot and sit there. And so that's something that we could standardize for next time. Another study limitation and or bias was that birds were recorded in wetlands along with nearby adjacent non-wetland habitats. So not only were we in wetlands, but like I said, we were moving around the area. So we may have wandered into a nearby forest habitat or other non-wetland habitat in the area and counted birds in those areas as well. And then human disturbances in wetland and urban habitats ranged from cars to hikers coming by, and this may have reduced numbers of birds recorded because the birds were hiding or fleeing or bird call sound distortion. So personally, when I was in my urban habitat, I found that it was very difficult to hear what bird species I was listening to when cars were going by. It was also very hard for the Merlin ID app to hear the birds as well. So this could have skewed our data in a way that we counted less birds than were actually in that area. And then our data was collected during fall migration dates. So according to the Farnsworth 2025 paper, this happens mainly from August through November, and so our data collection fit right in that zone. And you can see by this map that I found that 1.25 billion birds migrated the night of October 8th, 2025. So that's just this year, becoming the biggest night of migration yet recorded by Birdcast. So on this Birdcast map, I found it really interesting that you can see the heat map where in the arrows pointing south where a ton of these birds are migrating south already, and it's very bright in Pennsylvania, South Carolina, and then getting into Florida, whereas in Wisconsin it was pretty light in comparison. So that may have also been a factor in our diversity study. And lastly, here are our citations for this presentation, and we hope you enjoyed and hope you learned something new. Thank you.